So we're back here and back to our other screen. I edited a little by highlighting the hybridizations since we're going to use those every time we name. I didn't get to the oxygen here, but it's got two sigma bonds. There's a sigma and a sigma. It's got two lone pairs. That's 4. You put your 4 fingers up and you say that's sp3. And when we have sp3 and two lone pairs, that's just a bend you're looking at. So it's also called bent. Much the same as this one here. Now, if you're going to spend time on a test naming this bond, and then you redo the whole name here for the same bond, that's a waste of your time, and we don't like that. So find all of the bonds of exactly the same type and give them a very simple label, like maybe the letter A. And there's one more down. No, I thought there was one more. I think that's the only one where there's a hydrogen. And we'll try to get them over here. The thing I called A is clearly a sigma bond. The orbital hydrogen brings in is always S. You can put the S first or second, doesn't matter. The hybridization of the same carbon we determined here was sp2. So carbon's going to use an sp2 to overlap with the S. And that's the full name of bond A. I like knocking off the H's first. It's just a personal preference. Whatever order you go in does not matter. There's a lot of B's here. B and B. Yep, the hybridization of the carbon and nitrogen are both sp3. And the oxygen is also sp3. And this carbon is sp3. And B is similar to A, but it's a sigma. Now I can go with the hybridization on carbon first, just to show you it doesn't matter which one you put first, as long as you have both parts after the sigma. All sigma between an sp3 atom and an S on hydrogen. And that takes care of the H's. We don't have any H's attached to an sp atom. And I'm just going to go left to right to finish this exercise. Here's a C. It's a sigma bond. I like doing sigmas first and pi's for dessert, like I mentioned earlier. So there's a sigma bond between two sp2s, sp2 and sp. Oh, I didn't do this one. See, that's the problem with things the way they are here. This, I'm gonna need a little circle. That was for that one. We never did the carbon. Can I just put its hybridization down and highlight it? Because that's all we need right now. I just didn't get to that one. I had 3 sigma bonds and no lone pairs, right? So sp2 on the carbon here. We're working on this one here, sp2 and sp2. So that's what C is. I believe there's one more C in this molecule. Yes, the oxygen underneath, which I didn't do. I will leave it up to you, though, to verify. sp2. Once again, there's no points over here. This is all just me talking. You're getting the points over here. Yeah, that oxygen with 1 sigma and 2 lone pairs, that's 3 fingers. 3, sp2. So C is a sigma between 2 sp2 atoms. Here the carbon was sp2 and the oxygen's sp2. Here both carbons were sp2. We're going to go D up here. And there's probably more than one D. Let's focus though on what D is. The carbon below is sp2. Nitrogen above is sp3. And there's only one bond, so it's called sigma. sp2 to sp3. Let's go find some more D's in our molecule. We have an sp3, sp3. That's not good. We have an sp3, sp2. That's the same as an sp2, sp3. Remember, backwards, forwards, doesn't matter. So there's going to be a D right there, which is this one right here. And the carbon's sp2 and the oxygen's sp3. And I think we've got all the D's. If not, we'll catch it when we look at every bond and fill in the missing labels. Now we have an sp2 on this carbon. We're talking about this carbon to an sp on that carbon. That's different. sp2 on the carbon to the left to an sp to the carbon on the right. sp2 to sp. And that's an E, which I forgot to label. Keep our color scheme going here. Looks like a C. Okay. sp, sp3, I believe that's an sp, sp3. I don't know, looks like a P with an underline. Now it looks like a C. Okay, finally. There's a sigma between these two, which I believe is unique in this molecule. sp on both atoms. And there's a sigma between an sp3 and an sp3. Just verify that. Sigma sp3, sp3. We don't have a label for that yet. That's G. And looking above, I see another G. And that, I think, might be our last sigma bond. Almost time for dessert. Sigma sp3, sp3. Any sigmas missing? Yeah, that's a terrible B there. Okay. Nice. All right. And we'll do pi bonds in, I don't know, pi purple. Let's go with an H. Oh, purple's my molecule. Baby blue. You got to tell me it's a pi bond. And then you have to tell me what two orbitals came together to make the pi bond. They must be p orbitals and they must match. You want to go px, px? I got no problem with it. Okay. So I can call one of these the same, and I can call that one the same. But you got to remember your 141 days and what you learned about orbitals the first time you ever heard about orbitals. You can only use an orbital one time, whether it's an atomic orbital or a hybrid orbital or a molecular orbital. So you can't have the same name for two different bonds. So if there's a carbon participating in a pi using its X to another carbon, then the second pi has to be a different p orbital, and we'll call it pi pz pz. Once again, they have to match. Okay, so if a carbon participates in more than one pi bond, each pi bond has a unique name. And that's all of part A. A was done A, B, C, D, E, F, G, H. And then B, the little typo, missed an E in there, didn't I? We're going to determine the geometry around each central atom. And I'll just go to capital letters now. And we'll do it in pink. So I'm going to put a capital A right on the carbon. Trying another capital A here. And a capital A here. No, that's not a capital A. That's sp3. All my A carbons have to be sp2. There we go. We're talking sp2 and no lone pairs. We call that trigonal planar. Now on a test, if you're going to use a short form, you better give me the full form at least one time. So we're going to pretend we didn't have a short form on the other side of the page. Trigonal planar is actually a bit redundant. I challenge you to draw a triangle that's not planar. You can't. So what about B is unique here. That's a sp3 atom with a lone pair. So normally sp3 is tetrahedral, but a lone pair makes that pyramidal. Oh, I think somebody's trying to tell me I forgot to give the angle. They were right. So pyramidal and trigonal planar comes from sp2 geometry, and you got to tell me you know the angle's 120. I reversed it. I gave name first, angle second. You're not upset at me, are you? And pyramidal when it's sp3 is 109.5. Any sp3, 109.5. And we'll call this capital C. Looks too much like a carbon, and a lowercase c for that matter. We can skip letters of the alphabet. And those are both linear and angles of 180. And we have a trigonal, E we didn't do yet. We have a tetrahedral carbon there and there. And I think that's the only two. That's tetrahedral, 109.5. And I think the only atom missing, the central is just a fancy way of saying attached to more than one atom. That's an F. F is bent. We have two Fs. Bent. They're both sp3, so 109.5. There you go. It's got all 5 geometries that you need in this course. Isn't that good news? You had a lot more geometries than that in Inorganic 1. There's only 5 in this course, and there's only 3 angles you have to learn. And I don't believe I missed any central atoms, and I believe I have all of the bonds, sigmas and pi's, sigmas in black, pi's in baby blue. And I believe that's the end of that. And that's a good spot to stop for this segment. Do you have any questions? You can unmute yourselves if you have a question. In fact, if you see me make a blatant mistake, please unmute and say, "Excuse me, Dr. Whitaker," like was politely done earlier in other classes. All right, so we're going to stop this one, and then I'll see you in 5 more minutes.